Good morning, students. Welcome to Bindu Dhadwal chemistry lessons. Our topic for today is carboxylic acids. So, a compound containing COOH group is called a carboxylic acid. In this, the functional group is C double bond OOH. It contains both carbonyl group and hydroxyl group. So, combining the two, carbo of carbonyl group and oxyl of hydroxyl group, gives us the word carboxyl group. So a COOH group is called carboxyl group and the compound is called carboxylic acid. The carboxylic acids can be divided into two classes: aliphatic carboxylic acids, where the R can be H or an alkyl group, and aromatic carboxylic acid, where the AR can be any aryl group, for example C6H5. Some higher members of aliphatic carboxylic acids having carbon atoms between 12 to 18 are also called fatty acids because they are obtained by the hydrolysis of fats. Natural fats contain generally ester salts of glycerol. Nomenclature of carboxylic acids, we can name them by common system as well as IUPAC system. In common system, the name is derived from the source of origin. For example, formic acid HCOOH was found in the red ants colony. So the name formic comes from formica, meaning red ants in Latin. Similarly, acetic acid, acetum word comes from vinegar, which in Latin is called acetum. Similarly, butyric acid in Latin is called butyrum. It's obtained from rancid butter. And caproic acid comes from the word caper, which means goat in Latin. So these are the common names of compounds. In common system of nomenclature, to depict the position of a substituent, we use the prefixes alpha, beta, gamma, delta, etc. In IUPAC system, we name the compound by selecting the longest chain, carrying out the numbering of the chain from the carboxylic acid part from the functional group, and when we have to indicate the position of the substituent, we use the prefixes 1, 2, 3, etc. And at the end of the name, we use the suffix oic acid. For example, a 1-carbon carboxylic acid will be called methanoic acid. Meth for 1 carbon, ane for single bonds, and oic acid for COOH group. Similarly, 2-carbon compound is called ethanoic. This compound will be called 2-bromobutanoic acid because it's a compound of 4 carbon atoms. Similarly, when we name this compound, it's a compound of 6 carbon atoms and there are double bonds at 2 and 4 positions. So name will be hexa 2,4-diene oic acid. Similarly, aromatic compound, this will be called, because it's a compound of 2 carbon atoms in which a phenyl group is acting as a substituent. So the name will be 2-phenyl ethanoic acid. This compound contains a carboxylic acid group as well as a oxo or formyl group. So it can be called formyl methanoic acid, or it can also be called oxoethanoic acid. This compound is called benzoic acid in IUPAC system. We also have acids which have 2 carboxylic acids in the compound. So these dicarboxylic acids are generally known by their common name. For example, a dicarboxylic acid with 2 carbon atoms is called oxalic acid, with 3 carbon atoms is called malonic acid, with 4 carbon atoms is called succinic acid, and with 5 carbon atoms will be called glutaric acid, and with the 6 carbon atoms, a dicarboxylic acid will be called adipic acid. Then aromatic dicarboxylic acids also have common names. For example, 2-COH group at ortho positions to a benzene is called phthalic acid. At meta position, it's called isophthalic acid, and at para position, it's called terephthalic acid. Methods of preparation of carboxylic acids. First method is from oxidation of primary alcohols. We use oxidizing agents like KMnO4, potassium dichromate, chromic oxide in acidic media, etc. But KMnO4 in neutral or alkaline medium is preferred for forming carboxylic acids. In the process, when we carried out the oxidation in presence of alkaline KMnO4, potassium salt of carboxylic acid is formed, which on acidification can be converted to carboxylic acid. For example, ethanol will be converted to ethanoic acid, butanol will be converted to butanoic acid, and benzyl alcohol will be converted to benzoic acid. Then we can carry out oxidation of aldehydes and ketones also. Aldehydes are very reactive and can be oxidized even with mild oxidizing agents such as Tollens reagent to form the respective carboxylic acid. Ketones are oxidized with difficulty and also do not produce pure carboxylic acid. They produce mixture of acids. From hydrolysis of nitriles also, we can prepare acids, and we can prepare acids from hydrolysis of amides also. So when nitriles are hydrolyzed in acidic or alkaline solution on heating, they will first prepare amides, which on subsequent hydrolysis will form carboxylic acid. For example, methane cyanide or ethane nitrile on hydrolysis will form first ethanamide and then ethanoic acids. The alkyl cyanides needed for the purpose can be prepared from alkyl halides or alcohols. So let's prepare from alcohol. Alcohol, when reacted with potassium tribromide, will form alkyl bromide. This, when treated with alcoholic potassium cyanide, will produce alkyl cyanide. KBr will be formed as byproduct. This cyanide can be hydrolyzed into acid. Similarly, aromatic cyanides on hydrolysis will first produce aromatic amides like benzamide, and then on again acidification or hydrolysis will produce benzoic acid. The aromatic cyanide or aryl nitrile needed for the purpose can be again prepared from aryl halide or aryl amine via diazonium salt. So aryl halide, when treated with copper cyanide in the presence of pyridine, can form phenyl cyanide. This phenyl cyanide can be hydrolyzed with water in presence of alkali or acid to produce respective acid. Similarly, if we have to convert aniline to cyanide, we will treat it with a mixture of sodium nitrite and HCl at ice cold conditions to form benzene diazonium chloride. This benzene diazonium chloride, then treated with copper cyanide in presence of potassium cyanide, can produce this nitrile, benzonitrile, which can be hydrolyzed with alkali or acid. Then we can also prepare carboxylic acid from Grignard reagent by the action of Grignard reagent on carbon dioxide in the presence of dry ether. So the methyl group will be added to the carbon and MgBr to the oxygen of the double bond in presence of dry ether to form an addition product, which on acid hydrolysis will produce this ethanoic acid and magnesium hydroxybromide. Similarly, phenyl magnesium iodide, when treated with carbon dioxide, will again form an addition product, which on hydrolysis will give benzoic acid and magnesium hydroxyiodide. We can also prepare acids from acyl halides and anhydrides. So when acyl halide is hydrolyzed with water, the OH of water will be added here and H here to produce acid and HCl. So these can be readily hydrolyzed with base to form carboxylatides, which on acidification will give acid. So benzoyl chloride on hydrolysis will form benzoic acid. Acid anhydrides are also easily hydrolyzed with water to give the respective acids. For example, ethanoic anhydride will give ethanoic acids, benzoic anhydride will give benzoic acid. By hydrolysis of esters, carboxylic acids can also be obtained by hydrolysis of esters with mineral acids and alkalis. So water breaks up, the H will come here and OH here to form an acid and an alcohol. For example, ethyl ethanoate on hydrolysis in presence of acid or alkali will form ethanoic acid and ethyl alcohol. We can hydrolyze it in presence of base also. Sodium salt of acid and alcohol will be formed. This can be further hydrolyzed, can be converted to acid by acid hydrolysis or acidification. Carboxylation of alkenes. This is Koch reaction when alkenes are oxidized with carbon monoxide and steam. Alkenes are heated with carbon monoxide and steam in presence of phosphoric acid as catalyst under pressure at a temperature of 573 to 673 Kelvin. This water breaks as OH and H. The bond will break. H will be added here and COH here to produce propanoic acid. Similarly, in unsymmetrical alkene, COH group will be attached at the carbon containing less hydrogens to prepare 2-methylpropanoic acid or isobutyric acid. From trihalogen derivatives on hydrolysis, we can prepare this acid. For example, trichloromethane with aqueous KOH will form trihydroxymethane, which is unstable. Water is eliminated and methanoic acid is formed. Similarly, trichloroethane on hydrolysis will form trihydroxyethane, which on when water is removed will form ethanoic acid. Similarly, benzotrichloride on hydrolysis will form trihydroxy compound, which when water is removed from it will form benzoic acid. Preparation of aromatic acids from alkyl benzene. So this alkyl part can be oxygenated with alkaline KMNO4 to potassium salt, which on acidification will form acid. Any alkyl chain gets converted to the same product. It's a alkyl group of 1 carbon or 2 carbon or 3 carbon. It will get converted to benzoate salt only. The presence of electron withdrawing group increases the acidity, so such compounds are much more easily oxidized into respective carboxylic acid compounds. If the number of alkyl chains are more than 1, each of the chain will be oxidized to introduce a carboxylic acid group. For example, orthoxylene on reaction with KMNO4 and then acidification will form phthalic acid, and paraxylene will form terephthalic acid. In this, the presence of benzylic hydrogen increases the reactivity. So more the number of benzylic hydrogens, more will be the reactivity. So that's why a primary CH3 group when attached to this benzene is most reactive because it has 3 benzylic hydrogens. So primary is more reactive than secondary, is more reactive than tertiary. A quaternary compound which does not have benzylic hydrogen does not react at all. Next method is from methyl ketones by haloform reaction. When treated with sodium hypoiodide, this CI3 will be formed, and which will react with NaOH to form CHI3 or iodoform. If it's a chlorine, sodium hypochlorite, then chloroform will be formed. If it's sodium hypobromide, then bromoform will be formed. The sodium salt of acid with one carbon atom less is formed, which on acidification will form the respective carboxylic acid. So the carboxylic acid that is obtained is one carbon less than the parent compound. Methyl carbonyls also undergo haloform reaction to produce carboxylic acids. Oxidation of alkenes can be done with KMnO4, hot acidic KMnO4 or potassium dichromate solution. Then on treatment with dilute sulfuric acid, the respective acid will be formed. The reaction it breaks from the point of double bond. So when this compound will be converted to acid, RCOOH compound will be ultimately formed. Similarly, if butene breaks, it will form 2-ethanoic acid. If pentene breaks, then it's going to form propanoic acid and ethanoic acid. This is oxidation of alkenes. Then we can also prepare carboxylic acids by passing carbon monoxide over heated sodium alkoxide. So on passing carbon monoxide over heated sodium alkoxide under pressure, we get sodium salt of carboxylate ion, which on acidification will form carboxylic acid. An acid can be converted into its next higher homologue by a method known as anti-start synthesis. It is also, this conversion is also called homologation of an acid. It involves the following steps. Carboxylic acid is treated with thionyl chloride. So SOCl2, SOCl and Cl. So acid chloride, so SO2 and HCl. So SO2 and HCl is eliminated as byproducts and acid chloride is formed, which on reaction with diazomethane, one HO and one Cl will form HCl. CHN2 gets attached to form this product, which on treatment with silver oxide will form RCH2COH, the next higher homologue. RCOH will get converted to RCH2COH, the next higher homologue. This is called anti-start synthesis. Reaction occurs as the thionyl with the thionyl chloride, sulfur dioxide and HCl is eliminated and acid chloride is formed. With diazomethane, this gets attached over here. Now this compound is this. Here the rearrangement occurs, the negative charge comes here and alkyl group migrates to this carbon and nitrogen is removed. So as a result, this product ketene is formed. This happens on reaction with silver oxide and this conversion is called Wolff's rearrangement, and then ketene on hydrolysis is going to form a dihydroxy compound, which tautomerizes to form the higher homologue. So this overall this reaction is anti-start reaction, and this migration or this isomerization, this rearrangement is called Wolff's rearrangement. That's all in today's video. If you like the video, please do share and subscribe. Thank you. Have a nice day.